Okay, before we start, let me plug my charger. Also, I'm gonna have issues when I'm trying when when it's almost flat, and then now I must look for the charge. Tabang. Okay, so let's start. Okay, this was first years talking about arrays. I think you guys should. It's also important to watch this recording. C++ is related to Java. I'll make sure I send. The thing is, I forgot. Let me see. Is there anyone that needs to be admitted into the? Okay. Hey, the numbers are increasing today. Hey, 1 year. I hope the one who read from the binary file is attending. Okay, yeah, like I said, you guys do spiritual things. There was no reading binary file there at all. Let's see. We're doing 2020 paper, right? Yeah. I hope I didn't forget. I see let me see. Uh, yeah, it's this one. So we have this, it displays the results, everything, right? So we did all that. Um, do I still have the code? Snetemba. You are not unmuting and mute. No, you are not muting. Uh, let's see. Do I have it? Where did I put it? George. I don't know. But I think I did send it in the group. Where is it? Oh, it's down. It's there inside the Eclipse workspace. Uh, because there's certain things that I'm not doing right. Where is it? Is it this one, right? SRC Basic Collider. Okay. So let me open this inside Notepad++. So this is the code, right? Yeah, everything is okay. Micro, blah, blah. Yeah. So the thing that I need to check is the main. Yeah. Let me see something here. Okay, yeah, this was a different problem. Yeah. If it had involved text files, then yeah. But we're gonna do the 2024 one. Your structure is gonna be exactly like the 2024 paper. By structure, I just mean how it's going to be asked, right? That's that's what I mean. So yeah, so let's continue. It's fine. Because most of the time you get file handling, let me show you. There's something that I was neglecting. Even the code I sent you for the solution for the mock test that you guys had, that solution was missing like reading from the other two files because it said to read all of the files, all of them. So you're supposed to repeat that code inside your main function 2 more times so that you read the other two files. But yeah, I didn't pay attention to the all part, but yeah. That's why I'm trying to double check here if we did question one properly. Yeah, we did it properly. Now we can start question two. So you guys should grab your snacks, whatever, your coffee, and sit tightly because we are leaving the session at 10. So let's start. File handling and regular expression, right? So if the topic says file handling and regular expressions, right, you can see this is text files. Don't do a spiritual thing and do binary here. Hey, me out. If I was a lecturer, I'll ask you straight, hold you by the hand, take you, switch off that computer coding in. take you to the faculty and tell them, hey, guys, deregister the student. It's not serious. Regular expressions and binary. Hey, that would be a first. I don't know how you do such spirituality. How will you achieve it if you even manage to achieve it? People end up people actually developing their own programming languages when they're writing tests because there's no such thing as regular expressions and binary. But you see, someone who's gonna do what I'm talking about right now. The Utopian Waste Disposal Services needs a Java program to automate the processing of waste information. So we're just automating the process of the waste information. We're just automating that process. That's all. That's basically what we're doing here. So we need to create a solution that solves a problem. Remember, computer science, right, is applying mathematics computationally in such a way that you solve a real world problem. I just came up with that definition because it is true. You take a real world problem, like a problem from outside. You see, for example, you have a problem with money. You need to make money. You create you create an aviator for people to play, and then it goes up, goes down, they lose, you make money. You see, that's a problem that you solved. You wanted money. So you made an app called Aviator. Or you made a betting app, Betway. You know, a lot of people have lost their money. They and some people have a serious addiction. So it's taking a problem that you have and solving it, applying computers, basically making an app to solve the problem. That's what you are doing here in this practical. If you didn't realize it, you're actually doing that. So we're going to make an app. So let's make our app that reads a text file and it does what is this? And it uses regular expressions. So I need to go to my paper. I'll just call it Q2. Yeah, or question two. Then this is actually an Eclipse project. Yeah, this one is, but you see that most of the time it's not. How do I know it's an Eclipse project? You see the dot class path and the dot project. This tells you that it's an Eclipse project. So I'm going to open Eclipse, then I'll simply import it. But then I don't advise you importing and doing, yeah, don't import. I would advise you to create the project from scratch. Then you copy all these folders, then put it in there. So I'll just do that, whatever. Let me lead by example. So I'm going to copy all those files, go to my Eclipse, of which is taking its precious time. Personally, they should stop using Eclipse. They should use IntelliJ. IntelliJ is quite powerful, and that's the number one IDE for Java. So, and it's free. So I don't know why they're not staying up to date. That's why sometimes it's kind of hard to get employment as a person with a degree because you don't know anything about the industry. Everything is just being sugar-coated for you there at university. You're just enjoying the, just enjoying your life. Let me, yeah, so, yeah, let me not import. Let me do this. And then minimize, close. So I'm gonna create, what am I importing? My mind is conflicted between importing and creating. So I'm gonna call it question. Yeah, you cannot use a hyphen if I'm not mistaken. So I'm gonna use an underscore. Question two underscore memo. Let me write the paper 2020 ST2, comma, question two memo. I'll just name it like that. I think that should be fine. Then click finish. Then, yeah, then we have our project here. Then I'm gonna create a new class. But before we do that, let me go to here. Let's check the Java, what is this? The packages, right? You need to know the packages that you must use. You see, this is what I don't like. You see, when they don't give you the packages, it's kind of suspicious. Okay, this was a short question, I guess. It's kind of suspicious, but it's a short question, so it kind of makes sense. So there's no this thing packages, so you just write it in whatever it feels right, in whatever way it feels right to you. You can make your own packages, that's fine. But since we are not forced to, I'm not going to do so. Oh wait, we are given files, I mean. That's why. So we are working with files from there. So let me do that. So let me copy all of this and then copy it. Then you select the project over there, right? Then that project name, then you look for paste. You're gonna right click on the project name, then click on paste. Then it's gonna ask you whether you want to overwrite because there's another SRC folder. Just say overwrite all. It doesn't matter whether you overwrite none or you overwrite all. Then yeah, I was shocked why they didn't put packages because they like packages a lot. Then we're gonna use this jar file some way somehow. So let's see what we have. So we have main.java. I don't like this the ones whereby they give you the code. Do you see how much code we have here? And you need to understand it. That's already written for you. Am I seeing things here? Majority of the work is done for you. That's weird. Oh, we need to create another one. Okay. Am I using the right question? No, it's not. That's why, man. I felt yeah, I must leave weed. Hey, see now it's making me forget things. So let me copy this. Yeah, I'm busy putting other things. I mean, hey, uh, what should I do? Should I just? Hmm, it's fine. I'll just delete them. Delete, then delete data. That's okay. Delete docs. That's okay. Delete this. That's okay. Delete this package. That's okay. Then I'm gonna right click on the package project name, then paste again. Yeah, so this is the one. Yeah, we still have the jar file. I was looking at the wrong paper. That's why I was shocked. Like, why is it so mixed? So we have processed and unprocessed. So we need to use regular expressions. We've been doing that for quite a while, right? So now I'm not going to waste too much time on that. I'll just show the answer. The part where I have to explain it, I'll explain it. So let's see. Create a class, right, called waste file handler. And it is a static method. This time they told you static, but me, I always make my method static. So it's a static read waste method. The read waste method must accept blah blah. So one thing at a time, let's create the class itself. So src, I need to create my main class first. So I'm gonna say main, right? Tell it to create a main method, generate comments, right? Finish. Then I'm going to click on source again because there's no packages, right? So I'm not forced to create a package. So just add it in the same default package as my main.java. Then I'm gonna give it the name waste file handler, generate comments, finish. Yeah, and then that's pretty much it. So let me put the Java doc here with author Vortex Academy. Come on, at version. This is the 2020 ST2 question 2. Then I'm going to copy this, use it in this other file. This is for the case someone tries to steal your code, you can sue them, blah, blah, blah. Copyright, you can do all of that as long as your details are there. So you need to create a static read waste method. So it's static and it needs to be accessed, right? So that means you need to make it public. It needs to be accessible. So public followed by static and then followed by the return type. So this is where the return type will go, right? Then followed by the name of the function, then followed by our parameters, right? Then curly braces to define the scope. Remember, we talked about scope. So read waste, let's read continuously. So the read waste method, it accepts a file handler. To show you how much these lecturers are trying to help out you guys, but you don't get the hints. I can literally copy this as it is. Copy it and put it inside Java. They say that's the parameter, must file handle. You see, and then I import file. Done. So when they say file handle, they mean this. You should call it handle. I would advise you to give it the same name. That's you see that they're giving you a hint. I just copied and pasted. They actually gave me code, did they? Then here they said an array list of waste, which is exactly it's exactly what it says, but slightly different. So I can copy this. They said it should return, right? That's what it should return or give you back. So I'm gonna go back to my return type there, change it to array list of waste. But instead of waste, remember you put it in between the angle brackets. But then yeah, this is very good. You see, I did it step by step so that I show you the errors. So import the array list. Then you see the error here. It says, I don't know what waste is. Is it a type? I don't know it. Then you're gonna be like, matter how? Because in the prec they said it should be waste. How come it's not picking it up? Well, because of the jar file. We haven't linked our jar file to our project. It is actually here in the jar file. So we need to right click on the jar file, go to build path, and then click add to build path. Then now it's now part of our project. Then if I look at the classes here, I go to the package, you see there's unprocessed, unprocessed, there's waste, so it is there. Then now if I try to save again, right, I'll save again so that it saves the changes. I've linked my project, right? You see there's my jar file to my project. So now I can hover over the waste name again, and you see now it's going to show me an option to import because now it knows where waste is coming from. So that's why you need to really understand the steps and what you're doing in Java. So I've imported it, then we need Java doc. So handle, and then here you just say return array list of waste. That's what it returns. It returns an array list of waste. So since it returns or gives you back an array list of waste, we need to instantiate a local variable of type array list. So it's gonna have I don't know. Something tells me that it's very wrong, so I'm not gonna call it like that. I don't know what's the plural of waste. You can't say wastes. That makes no sense. So I'm just gonna say waste, but I just know it's multiple of those things. So waste is equals to new array list. Then I'm gonna return waste, right? Right, so I've returned waste. Then now we in between, so at line 20, starting from line 23, that's the part I'm gonna be reading from the file. So I'm gonna go back to my PDF and you're gonna notice that we need to create two patterns, right? See, there's the processed, then there's unprocessed, right? And each element, this is very important, each element is separated by a tab. That's important for what? String tokenizer, because we need to tell the string tokenizer what's the stopping point. Basically, it should split when it sees what character. That character that it should split it at. Basically, you split it at that location. It's like, for example, you are cutting chocolate, right? That part where you're cutting it, we can call that a delimiter because that's what sets the pieces apart. It's a delimiter. So That's what they mean. That's why they're telling you each element is separated by a tab, because they want to tell you that that's what should count as the delimiter for your string tokenizer, because they expect you to use the string tokenizer. So I hope that makes sense. So you should return an array list of waste read, you see, read from the file, right? So I'm going to highlight this. We need to read from the file. The read waste method must read each line of the file and determine if it's processed or unprocessed using appropriate regular expressions. They've told you that it's based on regular expressions. So let's do that. So remember the keyword static, we're not there yet, right, in terms of our intensive revisions. Remember, we just stopped and just went straight to question papers. But static, right, the word static, it means that it doesn't belong to the instance. What does that mean? It means that you don't have to instantiate an object to call that method. So you don't have to say new, then save it into a variable, an object, then use that object to call the method. No, you don't have to do that. Static, it means that it's part of the class. So you simply use the name of the class. So you simply say waste file handler like this, file handler dot followed by the name of the function, which is read waste. That's how we're going to call it inside main.java. But for now, you don't have to worry about that. But that's what static means. It means you can call the methods of the variables simply by passing the name of the class first, followed by that variable. They're static, meaning they're part of the class. Another word for it, they're called class variables because they belong to a class and not to an instance. To understand that terminology, I advise you go read the textbook. So let's create our pattern. So, and another rule for static, right? If you create anything that's static, let's say static class, I've never seen such, but there's no such, but just let's say static function, right? You create a static function, it expects you to pass other things that are static, because the way variables work inside Java, right? In any language, they can either be belonging to the class or they belong to an instance. There's no in between. If they belong to an instance, they're called instance variables or instance methods. You can call them instance methods, that's fine. But if they belong to the class itself, meaning that you don't have to instantiate an object to call the method, that means they belong to the class, not an instance. So therefore, they're called class variables. A rule about class variables is that you can only call other things that are belonging to the class. So you'd have to actually read the textbook to really understand that part. It's quite a lengthy explanation. Not too lengthy, it's like 2 pages or one, I think. Might even be a small paragraph. I forgot the textbook. Well, how does it explain it? So we now need to create a static. When I say static, because we have a static method, you cannot call something that's an inst. So the moment you remove static, it becomes what we call an instance variable, meaning to use that variable, you have to create an instance. Think about it. Would it make sense if you want to use, let's say you had the pattern here for processed. So let's say processed pattern is equals to pattern dot compile. Then you pass our regular expression in there, right? Then I'm going to have pattern and processed. And processed pattern. It's fine. Let me write it in full. I wanted to abbreviate it to processed and unprocessed, but then I realized that we still have to create matches for them. So you see, these are now what we call instance variables. Well, how do I know they're instance variables? They do not possess the keyword static. And Java will shout at you if you try to call these things. So let me show you. If you try to say processed, right? Yeah, do you notice something here? It's not showing as one of the list of variables that I can call because the method is static and these are instance variables, so they cannot be called in there. So keep that in mind, very important. And these variables, right? we are probably going to, what is this? We are probably going to not change them, so they're going to be constants, basically final. In C++, you use the keyword const, but in Java, you say if you use the word final, meaning that's the final number. We're not going to change it, or final thing, or final value. We're not going to change it any further. But then we said they are static. So I need to say static final. They are static and final. So static final, processed, static final, unprocessed. So these are what we call class variables. Class variables because they belong to the class. But remember how to name constants, capitalize. So this is actually wrong. I'd have to actually write it in like this, processed underscore pattern. Well, these are constants, right? They're still constants at the end of the day. So unprocessed pattern. So there it is. So now it following the right Java coding standards, right? Basically following the rules. So there's our constants. Let's come up with regular expressions. This should be very straightforward. So let's see. We have WSID space WS name space and a hash followed by the WS volume. So that's basically the format. So what is WS ID? It's a unique ID of the waist, 6 characters long. Yeah, so here you need to, I'm being very analytic now because I don't want to make any mistakes. So you see, they used the choice of word here was what? Character, which means that it can be numbers too. They didn't say it's 6 letters long. That's a different statement. You see, understanding English is very important. So I'm going to open this file, right? Let me open any example file, right? So there's an example file. Let's see here. You see here, there it is here. There's an example of a processed pattern, a processed item, right? So you see that it is the number 4 and the 1 and the 5. So as I had said, I didn't have to read the file. I can use my common sense, but sometimes reading the file, since you guys are beginners, it helps a lot. So let's leave the file any file open. So there's the file open here. So I'm gonna go back here. This is 6 characters long. By characters, they mean it can even be an underscore. Yeah, an underscore. Basically backslash W. So I'll use backslash W, right? So backslash W plus, meaning one or okay, not plus. They said exactly 6. So I'm gonna use curly braces to say exactly 6. So this is 6 characters. They said characters, not letters, not letters of the alphabet. If it was only letters of the alphabet, then in our regular expression, instead of backslash W, we're gonna say capital letter A to Z or small letter A to Z and 6 of them, because that would be letters of the alphabet. But in this case, they said characters, English. Characters is basically anything on your keyboard. All the symbols on your keyboard, they count as a character, including the numbers. So character means something different from the word letters. Then they're separated by a tab. So I need to put a backslash T. So after the name, what the ID, I mean, we put in a tab. Then we follow by the name, right? So the name is a string. They just said a string name, right? The keyword here is string. They didn't say letters, but I can assume it's somewhat, but it's still a string. A string is still a string. Kind of, yeah. As long as they don't say letters, if the only time you'd actually use only letters, right? It's when they say letters. So just know when they say string, a string can also represent any characters on the keyboard. So that means it's still the same thing as saying characters. So they're basically saying the same thing in a different way. So it's a string name of the waste plant. So it's basically the same thing. And they didn't give you a limit, right? So backslash W. So no exact number. So I won't use curly braces. It's up to you. You can, right? Remember, there's no one way of doing it. There's multiple ways. So this would be just a plus because I was not given the starting point or the minimum and the maximum. So I don't know how big it should be, but I know it should be at least one letter, right? Or one symbol. This plus, right? If for some people want to use the bounds, you can say starting from one up to, you don't specify the upper bound, which basically means the same thing as plus. Like I said, there's no right way of writing this thing, right? Let's make sure it matches the line. Then after that tab, then we have the last thing, which is the volume. So the volume, before you see the volume, right? Let's look at what's there. You see, before the volume, there's hashes, right? There's a hash. There's this hash. So I need to put the hash there in my regular expression. So I'm gonna say hash like this. You don't escape it, right? I know it's kind of tempting to always escape things, escape. No, escaping, you only escape if it's already reserved for something else. For example, if you wanted to add to say it's the symbol plus, if you wanted to say that, you would escape it to be backslash plus, so that you basically escaping, right? You can think of it as like it's a very, very bad example, right? Very bad. You're gonna have to forgive me for that, but I want you to really picture this thing. Escaping, right? It's basically running away from your current responsibilities to perform other responsibilities. Just like, for example, like I said, it's a bad example. I'm just random like that. So it's like when you know that joke on TikTok, yeah, when something goes wrong in the family, whatever, and the father wants to leave, he's like, I'm going to the shop to get milk, and then he never comes back. So he ran away from his responsibilities, right? So that means that's no longer something he does. Just like here, you have escaped it. That means the plus no longer works as a quantifier. Now it works as a literal plus because you've escaped. You've ran away from your current responsibilities to a different set of responsibilities. Its current responsibilities is to quantify, to say one or more, or yeah, it says exactly one or more. But then we escaped it. We put a backslash to say no, run away from those responsibilities or leave those responsibilities, do something else, which is just literally the plus. So we had to in this case we are forced to use the escape sequence, which is the backslash, because it already has a responsibility. But a hash doesn't have a responsibility inside regular expressions. So I'm just gonna put it as it is. So that notice that difference. So after the hash, we followed by you see, you need to be very analytical. Immediately after the hash, right? You see there's no space or a tab or anything there. So that means it comes immediately after the hash, the volume. So let's look at the volume. They said it's a double measurement of the number of tons of processed waste. If you check the file, look at the doubles. It can be 2 digit before the dot, 2 digits after, 3 digits after. So it varies. But we can see that at a minimum, there's one, at least one. You see, on both sides, before the dot and after the dot, there's a minimum 1 digit. So the pattern for a double, you say backslash D. Remember, backslash D just means 0 through 9. So backslash D plus, because I wasn't told what's the minimum. So it's 1 to infinite, followed by a dot. But if you remember what we talked about right now, escaping, the dot is already preserved for it is another responsibility. It in inside regular expressions. So if you if you want the literal dot itself, you have to escape that current responsibility to a different responsibility so that it can be the literal dot. So why do we have to escape it? Because the dot in regular expression actually means any character. So when C++, no, what am I saying? Actually, my mind's all over the place. When Java, right, looks at this thing, right, and it sees the dot, it's gonna look at any character on your keyboard. Like I said, characters are, it represents the letters or the symbols on your keyboard. So this dot means anything on your keyboard, even an and sign, even an open bracket, a closing bracket, even a minor, an underscore, even a plus. It means any sign, but that's not what I want, right? Because if you look at the regular expression that we're supposed to come up with is for a double. A double has a dot. It has two digits. In between the two digits, there's a dot, a literal dot, not just anything. So I don't want anything. I want a literal dot. So I'm going to escape it, backslash. Then after that, I'm going to say backslash D plus. And I think now it can actually make sense that these backslashes. If you don't say backslash D, right, Java is going to assume that you mean the letter D. So that's why we escape it. So that we tell it that no, I mean a digit, not the letter D. Even T, so that it doesn't think I mean there's a T there. Even backslash W, so that it doesn't think it's a W there. That's why we escape things. If you don't, it's not gonna run because it's gonna fail to match the lines, then it's gonna crash. You actually be kept at 40%. Yeah, it crashes if your pattern is wrong. I don't know if you've noticed that. Yeah, that's something I should mention. If your regular expressions for both of them are wrong, it crashes. It's gonna be kept at 40%. That's how much precision is required in the semester test too. If it, trust me, you should test it out. Put a wrong regular expression for one of them. It's gonna crash. So I'm gonna copy this. I think we're done, right? Yeah, we're done. Yeah, it's actually short. We're done. The thing is, I had to explain quite a lot on the escaping part, and yeah, the thing is, I want you to understand everything. So I'm gonna go back to my code. This is processed, right? Then I'm gonna, okay, before we do that, remember we need to put in the cap there, that thing, that symbol, followed by a dollar sign, so that you tell the Java that we literally mean this. There's no spaces at the beginning and at the end. And then paste. And yeah, there's the regular expression. Then I'm gonna go back to my regular expression, right? Then I'm gonna delete. How many things do we have here? We had 1, tab 2, right? So that means I'm gonna need to delete from here to there, right? Why am I doing that? Because if you look at your question paper, the first two things are the same for both files, for both things. It's WSID and WS name. They're both the same. So that's why I just simply remove starting from hash to the end, going to the end of the line. Then if you look at this one, right, it has an opening curly brace, right? And the closing curly brace. So we need to match it exactly. But then the space, remember the space over here, this is a tab. We need to make sure we have that there is. There's the tab. Then we go back to our question. Then we see that there's an opening curly brace. Then we put the opening curly brace. So I'm going to go back here. I'm going to put the opening curly brace. But you see, escaping, I hope I explained escaping perfect. Escape sequences, right? Or escape characters, which is just a backslash. Once you understand it, you cannot fail to understand why sometimes with certain things you need to escape. Remember that curly brace is already reserved for quantifying. Remember, we can say 1, 2, 2, and then we've quantified. So they are already reserved for quantifying so that Java or regex, regular expression system, whatever, basically Java, let's say Java, so that Java doesn't assume that this is you're trying to quantify something. Because if it sees this closing, it's going to be like, where's the matching one? And then if it finds the matching one there, somewhere there, right, it's going to be like incorrect syntax error. Because to use the quantifying, you need to put in the starting uh, number and the ending number. So obviously you won't have that. You can have some regular expressions here like the at symbol. Then it crashes. It's like, I spiritual things. I've never seen such. So that's why we need to escape it so that it doesn't get confused. We need to override. In a way, you can think of it as overriding. That's another way, if you can picture it in terms of use programming terms to explain it. It's like overriding a function. But then overriding a function that already had some code in there, then you override it, meaning you just delete what's there and you write your own thing. Basically, changing responsibilities. So backslash opening curly brace, then we're gonna have WS type, right? So let's check what is WS type. Let me do this. They said the string representing the type of waste. They said a string, which just means characters. So backslash W plus backslash W plus. Be very careful with backslash W, right? There's backslash W. I'm using small letter one. If you use the uppercase letter one, it means everything else other than a character, which means the opposite of what you're trying to do. And then it crashes. You're gonna be kept at 40%. Like I said, you should need to master regular expressions because if it regular expressions are gonna cause your code to crash, meaning it won't compile, meaning kept at 40%. So the problem starts with the regular expression. Go revise thoroughly on regular expressions. Be a pro. Do the homework I gave you. You don't, I so banana tune. And then just gonna put the at symbol, so it's followed by the at symbol. In regular expression, if I remember very well, yeah, there's nothing, yeah, there's no symbol representing at. There's no use of it doesn't have a responsibility in regular expression. So we can use it as just a symbol itself. We don't have to escape it. And then after at, it's volume again. Remember, we came up with a formula for volume. It's the same formula. And notice something after at and before at, there's no spaces. That's what they're trying to show you. There's no spaces there. So don't put spaces and do your own thing because you'll be answering your own question paper if you do that. So D backslash D plus followed by a dot, but a dot already has another responsibility. So we need to escape it so that we tell Java that we literally mean the dot. Then after the dot, it's backslash DW again. Then we're gonna have a closing curly brace, right? There's the closing curly brace, but we're not done. Remember closing curly brace is already reserved for something. It's gonna see, remember we escaped. This part is, you see this part, it's fine. We've already escaped it. So Java knows, oh, you mean literally a backslash, a curly brace, a left curly brace. Now it's gonna see this one, then it's gonna ask you, you're showing me the closing one. Where's the opening one? So it's going to have a question mark here. Where's the opening one? Then it crashes. That's the problem when you don't escape things. So we need to escape it, put a backslash there to say, no, I mean literally the symbol right bracket, right curly bracket. That's what I mean. I mean literally the symbol itself. So this will be the full regular expression, right? Then I'm gonna copy it. So we're done with the regular expression. So once you're done with the regular expressions, you should be somewhat done with the paper. Because if you know the code to read from the file, you're done. Especially text files, easy. You create a scanner. We never did input and output. We did output. I think input we didn't. Oh, we did carve. Yeah, we did. So scanner, I'm not gonna explain that. If we did something, I'm just not even gonna talk about it. You just see code. If you didn't watch recordings, that's a you problem. Then we pass in the thing we want to scan, which is the handle. Then it's gonna throw a file not found exception. So I need to catch that. So catch file not found. You don't have to type it word for word like me. You can just simply import it. It should, after you import the scanner, it should show you the error. And you're gonna say surround by whatever. You don't have to claim this. So this is my way because I know, I remember the exception that's thrown. But well, let's say you don't. You and semester test two. You have to just simply create the scan, right? I don't know how people students fail, to be honest. Java, I don't know how. To this day, it baffles me how students fail. Eclipse has everything about Java. There's documentation inside Eclipse. You want to know about something, you go over it like this. It explains it. You see, there's notes here. Everything you'd want to know about an array list If you want to access methods from array list, you simply use the name of one array list, use a dot. It lists all the methods that are there, including explanation notes on the side. So you have all the notes and you still fail. It's a you problem, that one. That's not sugarcoated. That's a you problem. This is not first year whereby you couldn't copy. Here you can literally copy. Everything is there in Eclipse. And when you write semester test 2, the lecturers, they don't tell you to switch it off, meaning you're allowed. So why not pass and get 100? So you see, I'm gonna show you right now one of the things that I'm talking about, using Eclipse to your own advantage. You see, I forgot the exceptions as thrown. Eclipse tells me which one is thrown. Then it tells me, do I want to add throws? You always avoid add throws. Always avoid it. Why? Because if you add throws, that means you can have a try catch in your main. I don't need a try catch in my main. So I'm gonna add the try catch here by clicking surround the try catch. Then it will put the code for me. It will insert it. Let me show you. See, bam. So I don't understand how you can say you're feigning this thing, whereas the answers are all there, and you don't have to cram which file, which packages are the classes stored in. You just simply right click and say import. So you see, we are choosing to fail. You are given all the answers in Eclipse. They won't tell you that you're given. You must use common sense, but they're there. But then they said most of the time, this is incomplete. You see here, we're not using ARM. So that means we'll have to have a finally block to close the scanner. But the question paper always asks you to use ARM. So let's look for it. Let me go back to the top. To automate H9, blah, blah. Yeah, but this is a 2020 paper. Like I say, like the lecturers always say, don't do past papers that are too old. Always look in between like 2 years or so. The last 2 years, 2024, 2023. If you start doing 2022, 2020 was COVID, online, totally different. You see here, they didn't mention about it, right? They didn't say use ARM. They didn't talk about it at all because there was no marks for it here. But in the recent, when you're writing on campus now, it always asks you about ARM. So we're going to use ARM. So you have to the only thing you need to do is cut that line for scanner. Then you put round brackets here, space there. Then within the round brackets, that's where you pass that whole line so that it puts the finally block for us. That's why it's called ARM, automatic resource management. It means that it manages the resources for me automatically. I don't have to type the code or put finally block or check if it's null. I don't have to do all of that. It does it for me. So we need to use ARM. So we're using ARM. Then within our try block, right, this is where we do something. And then if it throws an exception, it's going to go here. Then it prints an error, right? But then to be honest, this is bad because it's gonna show you the stack. What's that called? Stack trace, right? It's gonna show you the stack. Remember, I talked about heap and stack. It's gonna show you the stack, how the stack looks, and the errors and stack on the stack and everything. You'll understand the stack better in ComSci 3B, which is assembly, because you need to understand the stack in order to create the variables and everything. No, functions. In order to do functions, you need to understand the stack. So it's going to print the stack. It's not useful information to a user like you and me, right? So therefore, I'm going to say sysr, right? And then I'm going to press Control backspace and then press Enter. So now it's going to print an error message, which makes sense. Remember this exception, it says file not found. So that means if the scanner is trying to scan a file that does not exist, a file not found exception will be thrown, meaning I couldn't find the file. Simple. So I need to output a message that says file cannot be found, cannot be found. This is a better message than to show all those red lines. You're confused everywhere. They're just all over the place. So it's better to just put a print statement there. And then here, this is where you do something in the try block. Basically, it's called a try block because you try something here. If something goes wrong, we catch it. Why are we using the word catch? Because if something goes wrong here, listen to the terminology. Think of it from a real life perspective. When you try something and that thing you're trying, it can throw an exception. What is to throw? Think of it like a dog. You have a pet, right? And you throw something, right? Like a ball, like a tennis ball. You throw a tennis ball, and then you tell it to go catch. You see the words I'm using? Throws and catch. That's why they use the word catch here. So basically, I'm teaching you something deep. Exceptions, they actually operate in that way under the hood. You throw something, you catch something. That's simple. That's how simple exceptions are. You throw something, you catch something. That's it, done. That's the whole big fuss about exception handling. It's like throwing a ball to a dog, and then you tell the dog, catch it, catch the ball. So whatever we're trying here, remember I said we might not find the file, meaning the scanner throws a file not found exception. Since it was thrown, we catch it, like the dog catching the ball. Then you specify what exception are we catching. We are catching the file not found exception. Then after we caught the file not found exception, we output a message that defines that exception. Because if you just say print stack trace, a stack trace is only useful to a developer, not to a user. A user is like your granny. Do you think your granny knows logic? Do you think your granny knows hexadecimal? Exactly. Put print statement, don't print stack traces. I don't know why I forgot to mention that, but yeah. Sometimes you might not know the message you want to print, right? Each exception class, remember this is a class, a file not found exception, that's a class. And there's the name, there's the object, an instance of that class. There's actually a get message method. You can say e dot get message, and then it returns a string, then we print that string, which is the message. It is most likely going to say found not found, which is basically the same thing I wrote. But sometimes, like I said, you don't know what to write. You don't maybe you ran out of English bundles. You don't know what to say in English. Just call the method from the get message method from that exception class. Yeah, seems like I'm on fire today with my explanations, but yeah, at least you guys can understand. Yeah, that was a good analogy for understanding exceptions. So let's continue. We have our regular expressions. We're done. Now we need to read the file. So we need to read line by line. So we have this. We try to instantiate a scanner. After we've tried doing this, instantiating the scanner, we might actually not find the file. So if it was not found, we have an error. But if it was found, it goes to this try part, right? You see the curly braces, these ones over here. They define the scope of when everything, what we're trying to try, what we're trying to do, right? So now let's try that. So we're trying to read from the file, but then there's multiple lines in the file. Remember, there's multiple lines. So this is where a while loop is useful. So I need to say while loop. And why am I using a while loop and not a do while loop? Because there might not be any line in there, meaning zero or more. And the while loop is perfect in this scenario. A do while loop is perfect when you have one or more, meaning it needs to run at least once. I don't want to read at least once when there's no line to read because that's going to throw an exception. So that's why I prefer to use the while loop here. So while scanner dot has next line, right? I'm checking if it has a next line to read. Don't I know sometimes can follow the lecturers and whatnot, blah blah blah, the lecturer's memo. I would actually advise you to actually avoid the lecturer's memo by all means, because the lecturer might do spiritual things. Because I get he thinks is I don't know, like I don't know. Sometimes when you're too smart or you think you're too smart, there's a difference between smart and thinking you're smart and being actually smart. Because being actually smart, it means that you know that you must make sure to not complicate your stuff. Basically, simplifying things. That's why the great minds like Albert Einstein, they say that if you can't explain it simply, then you don't understand it. So people like to complicate stuff. They don't know. anything about anything. Don't be intimidated by such people. So last I saw his memo. He said has next. Why would you use as next? Because as next, do you know what has next means? It means it has the next string. Meaning I check, does it have a next? I check, does it have a next? Does it have a next? Do you see how long that takes? Whereby I can just use X as next line, whereby it just checks if there's a whole line that's available. That's one check. You see, I don't even have the masters that he has, but I'm already seeing his flaws. So, like I said, just because someone has some qualification or they speak and sound smart doesn't mean they really are. So, if you think about it, next is actually not quite a good function to use. You should use as next line. And that's why there's next line function is what is there to begin with in the scanner class. So I'm going to use that to my own advantage so that I save myself time. I check if there's a line and I need to repeat this. So while, why am I using while? Remember, a while loop is used when you don't know how many times you're going to run, which is true in this case because I don't know how many lines are in the file. You might say, yeah, you know, because it's a text file. What if it's a binary file? Do you know how many lines are in there? Exactly my point. So while loop is very useful. We need to use that so that you continuously check how many lines are there to read. Then while, remember, it can run zero or more, right? Meaning it's going to start by checking first. It checks, is there a line to read? If it's true, then within this curly brace here and here, which is the scope of the while loop, then we do something if there's that line exists. What should we do? Step one, we store the line. That's the very first step. Always the first step. So string line is equals to scanner, because remember the scanner object is the one that is linked to our file, right? Since we've instantiated a new scanner passing that file, then I'm going to say scanner dot next line. I'm going to use the next line method. Like I said, Eclipse has documentation for everything. You see, it explains here even the exceptions that are thrown. So you don't even have to actually cram anything. You see, even shows you the exceptions that are thrown. So to be honest, you don't have to cram nothing. Just use Eclipse to your own advantage and copy. So next line, press enter. So there's the next line method, right? So this gets the whole line. It gets this whole line. And it stores into a string. So I'm gonna demonstrate what I'm typing as I go, right? So basically the string line, the string code line, it has this actual string, which is the first line, and then it puts double quotes so that it forms a string. Remember the spaces in between, these are the tabs. Yeah, this is a perfect, yeah, this today, yeah, and I'm on fire today. I'm gonna explain this thing until you get it, even if you are doing grade 5, you will be able to see it. So we've read the line, but there's something very important you need to understand with files, especially people doing computer science and statistics. You know that there's thing called data cleaning, right? You need to clean your data, make sure it's in the right format so that you can use it to come up with predictions or graphs or charts, all those things. Because data can be dirty, right? The data can be dirty. So the statistics students should understand this. So you see, it can be dirty in the sense that you see there's a weird space there, right? Some space there, or a new line, something like this. Let's say the whole string is like this. It is a new line and things like that. Do you see all those unnecessary spaces? Computers are they are perfectionists. If you thought you've met a perfectionist in real life, trust me, that was only 1% of how much of a perfectionist the computer is. So you see all of this space, right? Let me show you how much space is there. It's from here up until here. So you see all of this space, all of that. There's a method that can delete that space. It only looks at the end of the string and at the beginning of the string. Why at the beginning? Because at the beginning, you might also have some space there, which is this space, which is unnecessary because if you use the tokenizer, you start to get errors. That's why you need to be very much of a perfectionist if you wanna kill this thing. So you see, let's assume we always go under the assumption that things are wrong. That's basically how you basically prepare for the worst. You become a pessimist. You be like, if anything could go wrong, then it could go wrong. Something like that. You just hope for the worst. So let's hope this is the worst case scenario. We have a line which has so many spaces at the beginning at the end. So we need to update that. So I'm gonna say basically clean that data. So I'm gonna say line is equals to line dot trim. There's a function called trim. To trim, if you think, okay, think about it in terms of, let me do this. Yeah, I want you to use your imagination. In life, you won't amount to anything if you can't imagine. So I'm gonna force you to imagine. Imagine that if look, you see this string, right? Think of this space over here as the edge. For girls who do edges, think of this as your left hand side, right? On your side, this edge is on the left hand side. Then the edge is on the right hand side of your head, right? Or vice versa, in whatever way. But just know these are the edges. So you can trim your edges. Or for gents, you get a taper fade, and then these are the edges, and you're like, hey, Baba, do me right. I need my hair, I need that. I need to be trimmed. I need to be proper. Trim me proper, right? If you don't remember how they trim, they remove, right, all those things that are not that shouldn't be there. Basically, if your hairline like is not proper, whatever, it's not like aligned in a nice way. They kind of create a shape, a new shape, right? And they use the word trim, right? So it's exactly what we're doing here. We're trying to trim, make sure this looks neat and cool, so that we can impress that person we want to impress. So we've trimmed that. Now we know that our string is now proper. We know that it's in the right format, even if in the worst case scenario. And you see that I'm reusing the same string. It's up to you. You could have created another string, but what's the point? There's no point in declaring all those variables. Remember, every time you create a variable, that's memory being allocated. That makes this app slow. That's why when you play some games on some cheap phones, I get it freezes. Or a cheap laptop, it freezes, right? Because the developers who were making those games, they use languages like Java. Java is heavy. So you need to be very like be a perfectionist in programming. It actually forces you to be a perfectionist. Think, 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 think. Use all your brain cells. So after trimming, we have that string, right? So I'm gonna do this as an example, right? I'm gonna put it as a comment. So I'm gonna put it here so that those who've attended they can understand what each line is doing. So here I'm gonna put those spaces on those edges so that you can see that this was before. So this was a string before, then we trimmed it. There's no spaces on the edges, right? So my edges look good if I'm a girl. Or if I'm a guy, my trim looks proper. So after we've trimmed, now we look proper, we are good to go. Then we've read the line, right? Now we need to check if that line is a processed waste or unprocessed waste. Using regular expression, how do we achieve that? So we have a pattern, right? We have the patterns they are there. We need to create what we call matches for each patterns. And what I'm going to do, right, it might look weird to you, but trust me, I understand what I'm doing. It looks weird to you, but I know what I'm doing. I'm going to declare them outside the while loop. So I'm going to create matches. So I'm going to create a matcher for process. So processed matcher is equals to null. For now, it's null because we need to initialize it when we actually in the while loop when running when we're reading the lines. So unprocessed matcher is equals to null. So these are the matches, right? Why are they called matches? Imagine you're on a dating what show, whatever, and then someone is doing the matchmaking. So they're trying to check if you guys match. That's the whole point of it. Hence it's called a match. Like I said, if you understand English, I'm gonna reiterate. If you know English, life is gonna be so smooth for you. You'll be smooth sailing in every module. because it's actually telling you what it does, matcha, because it matches things. So I need to initialize the matcher. So when you initialize the match, right, you're gonna give it use the name. It's called, let's start with processed match. So this is my processed match. I'm gonna initialize it, right? It's initialized to what? Basically, remember this pattern, right? Data type. It starts with a capital P, meaning it's a reference type, meaning it's a class. So this is actually an object. It's a constant object, meaning there's methods on each of these constants. So now I'm gonna say each pattern, go to each pattern and initialize it to its equivalent matcher. This is process pattern, and I'm initializing the processed matcher for it. So the pattern class, it has a function called matcher because we are matching. So I'm gonna say dot matcher, followed by the thing you want to match it with. So in this case, it's the line that I've read from the file. So I want to check if that line, remember that's what the question asks you to do. He says, and read each line and determine if that line is a processed waste or unprocessed waste. That's exactly what I'm doing. So I want to do matchmaking. You see this part over here. This is when we initialize the matchmakers, right? So basically, we put the matcher. You see that the matcher is in between. Like this, the matcher is in between. Is matchmaking you and your crush over here. This is your crush, the line. This is you over here doing matchmaking. And we store the matcher, right? Or basically that set. Basically, it's like, imagine, how do I put it? Let me like I said, I want to make you guys imagine. Imagine you have a hula hoop. If you don't know hula hoop, Google it now. You have a hula hoop, right? And then they put you guys, both of you inside the hula hoop. So this will be you and your crush, and you are inside the hula hoop. Then we can give that, imagine that hula hoop is a label called couple A, something like that. So this will be where how we reference you guys. So hence I'm gonna store it in its own variable called process matcher, because this is for processed. Then I do exactly the same thing for unprocessed. So unprocessed matcher is equals to unprocessed pattern. Exactly the same thing. So we need to create a matcher for that dot matcher and match it with my line, right? And then we give a label for that. Then now we're gonna check if you guys are compatible, meaning you're exactly the same photocopy. That's basically, this thing of like, I know I don't like him, like we don't click. Yeah, I know we don't have that thing. Now we are checking if you guys have that thing, whatever that thing is. Whether maybe both of you guys like movies, whatever, like Game of Thrones, whatever tickles your fancy. That's that's the English for you. It's called tickles your fancy. You should Google that that saying. So if processed, remember we've created our matches, right? So if processed matcher dot matches, right? Meaning, yes, we found a match. Our couple matched, right? Their personalities don't clash. So we're gonna check if they match. That returns true or false, because it could be true that they matched, or it's false that they matched. And in our case, it's the lines. We're trying to find which line is a processed, which line is an unprocessed. I wouldn't advise you to use else here, right? I know I know if it's not a processed, it's most likely gonna be an unprocessed. But remember the files that they gave you, they also include data that doesn't match any. So that's why instead of else, I'm gonna use an else if to check another different condition. So check if it is unprocessed, right? If unprocessed matches. Basically, when you call the matches method, it checks if this pattern matches with that line that I've read from the file. And then if it's not, then we go to the else if. We check again. It checks if the unprocessed pattern or the regular expression matches with the line. That's what this part does. It checks if it matches and then returns true or false. Then once we've found the lines that match, right? And remember, we did talk about this. If you create an array list of type of and the data type is the name of the base class, you can add subclasses of that base class. It's gonna allow you. Because if you choose one specific one, you'd have to create two separate arrays, of which you can't return two separate arrays in a function. So that's why we always choose. That's why the people made Java. They thought this through ahead, way ahead. They're way ahead of everyone. They're like, oh, okay, we know that they're gonna try this. Let's allow this to be possible in Java. That you can pass child instances whereby you created an array list of type base class so that it saves you time. Imagine you have to create imagine you have 16,000 subclasses. That means you're gonna have 16,000 array lists. That's madness. Whereas you can just create one array list and they just use only that one. You see, now instead of creating 16,000, you only created one. For now, it looks unnecessary because you guys are doing basic stuff. This is easy stuff. In the industry, doing proper stuff whereby you see on this left hand side, instead of having two classes, maybe a 300 classes. It's not even a joke, like around 330, some small companies 30, 40. Basically 40 .java files. You're managing them as a group. So for now it might look useless, but trust me, there's a reason why it was made. It helps quite a lot. So we've read the line. So now let's try to understand something very important here. So let's look at this part, right? So this is our file. We've read the line, right? It's stored into the string. Remember, the line is stored inside this variable called line. There's that string. There's a comment that show you it's stored in there. Now we need to tokenize it. So before I tokenize, I need to go outside the while loop. Why am I always creating my things outside the while loop? Because if you create them inside the while loop, they're gonna be recreated every time. That's gonna waste memory. That means if on each iteration, basically to read line one, you create the variables. Then by the time it gets to the end of the for loop, it deletes the variables. Then it goes back to the condition at the top. It checks, is there another line to read? If there is, it creates new variables again. Do you see how much space you're wasting by creating and creating and creating? Whereas you can just create once outside the loop. So string tokenizer, even this should be outside the loop. I'll just let it slide for now. Then I'm going to call the variable tokens because it represents my tokens. Why are they called tokens? They're surrounded by what we call white space. White space characters or just white space, meaning it's invisible space. You see that there's no character, just space. Anything or any string that's surrounded by spaces, we call it a token. So since there's more than one token, there's tokens, plural. So therefore, I'm going to say tokens. If you notice how I name my variables, there's always logic behind it. I don't just say X or M. Sometimes if you want to understand my code, try and read the names of the variables. They'll give you a bit of explanation. Then you need to instantiate it, but before instantiate it, we can't do it here, right? Let's put null. Let's make it null for now because we need to instantiate it in the while loop. Because why? Because in the while loop, that's when we read the line. So after creating my measures, I instantiate my string tokenizer. So new string tokenizer. Then I pass in two parameters, right? The first parameter is the string that you want to split up. The word tokenize, right? It means you want to divide the you want to divide the strings into multiple strings, of which those multiple string, each of those strings, we can call them token, a token. So therefore, you want to divide the string into multiple tokens. And how would you divide? How would you split them up? Basically, you need to understand what is that space in between them. You see, they told you here. That's why this comment was there. Each element is separated by a tab character, meaning that when you copy a line from the file, this space is in between. It's a tab. So that's our delimiter or where we're going to cut. Imagine a chocolate, right? I want you, hey, you need to use your imagination today. Imagine this is a chocolate, right? Where whatever that brand is. This is the chocolate right over here. And then if you remember the shape of the chocolate, after some pieces, right, in between each piece, there's like a curved line, sort of, whereby you break it. You see that curved sort of like line there, that curvedness there, whereby you break the chocolate. We can call that the delimiter. Basically, at the point at which you break the string into tokens. In our case, we are breaking when you see the tab. Yeah, if you don't understand after explaining so much, I don't know, Nami. I don't know. So you can imagine this space, right? It's called white space characters because it's invisible, you can't see it. But then under the hood, Java is actually like this. It views it as like this, backslash T. Remember, backslash T means tab in coding, right? In coding terms. So basically they're separated by backslash T. That means that's where we're going to cut them, the strings. So when you create a string tokenizer, we need to pass in two things. The string itself, which is line, comma, the delimiter, which is the point where we're going to cut the chocolate or the string. So where are we going to cut it? When you see a tab, that's the cutting place. That's where we're going to take the knife and cut the. I should have used these examples, right? In the previous, in the past, I should have used these examples. They would have made token understanding string tokenizer better because I know people love food and they can imagine it's food. So there's the string tokenizer. It's instantiated, right? Then what this does, right? You see this line over here, right? What that I've highlighted. It splits it up, it cuts them. So it looks for the spot where to cut. The spot to cut, we call it the delimit, which is the backslash T. So and it by default it saves them into a string. It gives you back a string. So if you want to if a double or an integer, you'd have to cast the string to that numeric type. So this is how it works that line that I've highlighted, the line that instantiates. And you need to also know how many tokens or how many strings are there, or else it's gonna crash again, kept at 40%. Like I said, this is a question of you need to be precise. No room for errors. One error kept at 40%. That should be a song in your head. One error kept at 40%. One error kept at 40%. That should be your theme song. So you're gonna this is how the string tokenizer works. You're gonna read A, C. Is it delimiter? No. Is it the delimiter? No. Is it the delimiter? No. Remember the delimiter is like the stopping point. And then it reads, is this the delimiter? Yes. Then it cuts there. Then pa. It has cut it there, right? Where there's the tab. Since it has cut it there, remember that tab is no longer existing, right? Because when you cut there, I get that piece is already split up, right? So now we have the first string. Then it keeps on reading the second string, right? Then 1, 2, 3, 3, 4, 5, 6, 7. Then it gets to see the tab there. Then it says, oh, that's the cutting point. So let me cut there. It cuts it there. Then we have a second string. Then it reads and reads. Then we have the third one. So basically, these are the strings that we have three. So you need to, how do you call them? It depends on the number of times you've called it. So I'm gonna to call it you put in the name of your string tokenizer object, then you call the next token method. Basically gets the next available token. Then you're gonna call it again here, right? So basically you look at the number of times you've called it. That's the important part. This is the first time you've called it. So this is one. This is the second time you've called it. So it gets the second token. This is the third time you've called the function, so it gets the third token. So that's something you should understand. You call it more than the number of times you should call it kept at 40%. Akudlalwa la, this is COM-side 2A. Basically, that means I'm going to call next token for 3 times. If you call it for the fourth time, there's no fourth token here. It's going to crash here, and you won't know. It will just point to that line and say it crashed. I know something went wrong, but I don't know what. You figure it out. That's what Java is gonna tell you. So that's why you need to be very, very careful. That's why I'm taking my precious time explaining this because I know people like to do spiritual things. So there's the strings, right? So I'm going to, since remember it's common for both processed and unprocessed. So therefore I'm instantiating it outside the if statement. Not because if I instantiate inside the if statement, this is what's going to happen. I repeat myself because I'm going to need to do the same thing here and here. Why would I do that when it's the same thing? So you shouldn't repeat yourself. Programmers are lazy, remember. We don't like to repeat ourselves. So we need to understand the file, right? Let's say start with processed. Remember, process is the one line like this, and it is a hash. So that means with processed, I'm gonna take my precious time to explain this. I want you to really see what goes into planning this thing. So you see, so let's say we read the unprocessed. Remember, it's gonna be changed into one string because the next line method reads the whole line and then stores that whole line in a string. Remember the spaces, we were told that the spaces are tabs. So that means when we split up this thing, when you see a tab, we split it up there. See another tab, we split it up there. So now we have three strings. That means okay. That means I think for both, right? Yeah, yeah. For both processed and unprocessed, we're gonna have three tokens. Yeah, for both. Like I said, you call it more than the number of tokens that are available. Kept at 40%, it won't compile. So we have this, right? The tokens here, and then we have this, this is unprocessed, right? This is unprocessed. This is processed. As you can see, I also have to call the next token function three or maximum three times. And I need to get all of the inputs, right? So that's three times. Remember, the first token represents WS ID, and then the second token represents WS name. So WS name, and then the third one represents the volume, which is a double. But notice I want you to understand something. Notice this is a string. Is this a string? So there's quite a lot we need to fix in the string here. Like I said, there's a lot that goes on into planning this thing. It's not just code that you write for fun. You write the code because you've thought it through in your mind and you know how the solution looks. Then you write the solution. So now let's read. Remember, the tokens are stored inside that's why I called it tokens in plural, because this tokens variable or object, it stores all the tokens. So if it is a processor, if a processed one has been found, then we need to read all three. But then, like I said, I don't like declaring my variables inside loops. So I'm gonna declare them outside. Let's also declare line outside too. So string line, comma, let's store the things that are common, WSID and WS name, which is what is waste ID and waste the name of the waste plant, waste name. Yeah. So I'm gonna say waste ID, waste name, right? Then you can initialize them to empty strings. Yeah, for those who wanted to skip whichever revision, I think I did. This would you would understand this when you're revising Java. Then this needs to be deleted because it's now declared outside the loop. So that I save a bit of time because creating the things, it takes time. So if you keep on repeating it in a while loop, yeah, what if the while loop runs me 1 million times? That means it's gonna be created 1 million times unnecessarily because it's the same thing. Why would you keep on redeclaring it? Then there's only some exceptions. We'll get to that. So let's read the waste ID and the waste name, right? Remember we have tokens. Let's notice something about these tokens. Did you notice something here? The first two tokens are okay. You see that they're fine. They're in the right format that we expect, which represents the WS ID and the WS name. So they're in the right format. There's nothing to change with those strings. So I can just simply read them. So waste ID is equals to tokens dot next token. So you see, this is the first time I've called the next token. So that means I'm actually extracting the waste ID. Then I call the next token again to get the waste name. This is the second time the next token function has been called. Then the third time, we need to call it to get what? This information. But okay, we're not there. We're doing processed. We need to get the volume. So this is a volume in string form, right? It's up to you whether you want to read it in string form, then do the changes, then cast it to a double and int. That's up to you. In this case, we actually have to do it in that way. We need to read the string first, basically store it in a string variable. Then after storing it in a string variable, we do some changes. Why some changes? If you try casting with this hash symbol over here, it's gonna crash, kept at 40%. So you need to replace. There's a function called replace, which replaces a symbol. So we need to replace that hash with just nothing. You see that is nothing. How do you represent this line nothing? You simply a string like this. You see, it's just the line nothing. So we need to replace that. So I'm gonna put back that hash and then go back here. So now I'm gonna read. You can create the string again up here, there at the top. That's fine. But I'm just gonna create it here. So this is I'm gonna use the keyword str, I mean, so that you know that this is a string representation of the volume. So it's still not a double yet. So tokens dot next token. So there's the string, right? Basically let me put a comment here. So the hash 12.4, come on, it's 12.4, right? Yeah. So that's what SRT volume stores. It will read the next one and the next one and so forth. So it will read this one, read this, read this. It'll keep on updating on its own. The code we're writing is to read every line and handle it accordingly because all the lines have the same pattern. They have the same order. So we do the same thing for all the lines. So I've have the string. I can remember what I was talking about. You can replace the symbol. We call this function called replace. So I'm just going to reuse the same variable. I won't create another string. So when I say SRT volume is equals to SRT volume, remember strings are immutable. So when you call a method on a string object, right, it actually creates a new string. So you need to store the new string in a different variable. What you can do, right, is you can just reuse the same variable to save time. So I'm going to say SRT volume dot replace. Then I pass in the first character, which is a symbol that I want to replace here. Then the second parameter is a symbol that I want to replace it with. So we talked about this. I want to replace it with what? Just that. Nothing. Basically that line, nothing. Then which symbol do I want to replace? I want to replace the hash. So now what Java does, it deletes the hash. So now we have a double. You see, this is a double. Now, when you cast it, it's going to work perfectly fine. Do you know what casting actually does? I know it's stupid, but casting actually does this. It's simply, if you remember in high school, whereby you cancel like terms or whatever. If you're doing, I forgot that word or that topic, whereby you have a numerator equation and the denominator equation, and then if it's common, like x minus one, then you cancel them out. It's similar to that. You cancel out. Java just simply cancels out double quote. That's it. So that's why we had to remove the hash because if it's canceled out the double quotes and it saw the hash, crash because hash is not a number. So yeah, there's quite a lot of critical thinking involved here. It's small steps, it's small things, but then they'll make your code be capped at 40% if you don't follow protocol. So now I have the right string, it's in the right format, right? Now I cast. So I'm gonna say double, and then now I'm gonna just call it volume is equals to. How do you cast? We did, I think we did talk about wrapper types. I'm not sure, but I think we did mention that. But there's a function called each primitive type, right? It has a class that represents it. So those each class that represents each primitive type, we call those classes wrapper types. But no wrapper, not like the person who raps, like rapper like that. It has a W. So it's double volume is equals to double, and the most of if you check all the class names, they always start with the capital letter because that's how you name classes in Java. So you can use like I think one pass double value of new. Yeah, I think you can do it 4 times. You can actually implement this, what I'm about to do right now, 4 times. But I'll show you one approach. So I'm gonna say double dot value of. So you always call the value of method, which takes in any type, which can be a boolean, can be whatever, then it converts it to a double. So what are we taking in? It's a string, which is the str volume, which is the string representation of the volume in string form. We're trying to cast it to a double. Then it does what we call auto unboxing. Go revise. I'm not gonna touch on that. So now have we have to remember, we have this array list. We need to add the waste to the array list. So here we need to add our unprocessed waste, right? So I'm gonna say waste dot add, right? It expects a waste, anything that's of type waste. Remember, the subclasses are also type waste because of is a relationship. A processed waste is a waste. So that's why I'm able to add it to a waste array list. So I'm gonna say processed waste, right? And then we need to create it a new process waste. So a new, call the constructor. Then there's the constructor. Let's check the constructor. It expects 3 strings. It expects 3 parameters, 2 strings and 1 double. And if you can just double check, but I know it's gonna expect a waste ID, waste name, followed by a volume, and then done. Then you do the exact same thing for unprocessed, but then unprocessed is slightly different. It's quite a lot of work for unprocessed. Let's do unprocessed, then we finish with that. So let's see. Oh, I wanted to show you the thing. Let's check here. Yeah, you see, sometimes when you double click on there, it doesn't show you the code. So you actually have to like kind of guess, yeah, yeah, it's gonna be in that order. One thing I've noticed, right, the way they create their constructors, they always pass it in the same order as the order in which they are stored in the files. If you start by getting the waste ID, the constructor will take in a waste ID first, then followed by waste name. The constructor also take a waste name after the waste ID, and so forth. So that's why it's important to read them in that order, and then just simply call the constructor and pass them in that same order you've read them in. Remember, we need to repeat this next token, these 2 lines, because they're common in both files, right? Waste ID and waste name. It's common in both files. And then remember, we talked about this, right? You see the string over here. We have a waste type and we have this volume, right? So if you go back to the PDF, you see we have WS type, which is the waste type, WS volume, which is the waste volume. So we need to extract those. We need to call string methods. So understanding strings is quite very important to get if you want to pass this semester test. Strings is a very important topic. That's why I sent you a lot of homework. Then you decided to ignore me. It's most of you. I know. You don't have to tell me. I know some of you ignored the homework. So there's someone who hasn't even done one homework. I know for a fact. There's always those students. Then they end up doing voodoo on the ones that are passing. I just don't get it. Sometimes when you have the brain of a fish, a small brain, hey, yeah, we have waste type and waste volume. So let me go back to Notepad plus plus. Yeah. So we need to call the tokens, the next token, the third time. The third time we call it, we have a string representation of this, which is I don't know what you can call it. I like to call it whatever. I'm just that random. I'm just gonna call it input or values. You could call it values. You could, but values. Nah, let me not use it here yet. So I'm gonna say input. Then I'm gonna say tokens dot next token. Why am I storing it as a string? Because you can't save this. This is neither a waste type nor a volume. It's both. It has both. So we need to extract them. That's why we do string manipulation. What's the first thing we need to do? Replace this curly brace with and also that curly brace. We need to replace those, basically remove them. Replace, it's actually removing the thing. It's a nicer way of saying you're removing the thing when you call the replace method. So now let's replace it. Let's update the string. So input is goes to input dot replace this opening curly brace with nothing. Basically remove it. Then we repeat that same thing for the closing curly brace. So now I want to replace the closing curly brace. Now the string looks like this. So this is gone, that is gone. Then what comes to mind now? You need to think again, critical thinking. String tokenizers. So we have a delimiter here, which is at, because remember we have WS type, then we have an at symbol, then we have WS volume. So we need to split them up, and the part we're going to cut it at, we're going to cut it when you see the at symbol. So we need to create another string tokenizer. So yeah, it's quite a lot of work here. So I'm gonna say comma here, give it another name. So I'm gonna say other tokens. Yeah, I'm gonna call it other tokens. Initialize it to now, then come here, instantiate the tokenizer, right? So other tokens is equals to new string tokenizer, right? And then what are we tokenizing? It's the string itself. Remember, it's what? It's this string, which is the string that stores the third call to next token, of which I've called it input. So that means I'm going to pass input here, comma. Then what is the delimiter? Basically, where are we going to cut the string into tokens? We're going to cut it when we see an at symbol. Then we have our tokens. We need to know how many tokens. You see why it's important to understand your code. It's going to cut it here. That means it's going to look at the at symbol, cut it there. Then we're going to have two tokens. You see, we have two tokens, basically two strings. Then we need to use, that means you need to call the next token twice. So I'm going to have string here because the waste type is of type string, right? If I'm not mistaken. Is it of type string? Let's think about it carefully. Nah, it's capitalized, so I'm assuming it's an enum. Let's check if there's an enum here. String. Oh, this time around they use a string, yeah. So it's a string. But then sometimes it could be an enum. So I'm going to have waste type is equals to other tokens. Remember, I'm getting this waste type from the second string tokenize dot next token. This call to this next token stores the first token, which is recyclable, which is the waste type. Then you need to call the next token for the last time, which is the second time. You need to make very careful decisions here. Make sure that you call the next token function as many times as the available tokens. There is functions called has next token or has more tokens and has more elements. There's those functions that you can use, but there's no need for that. You can use common sense. You can use those functions, right, when you don't know how many tokens are there. For example, it's a very big file. Maybe each line you don't know how many, and it varies. Sometimes it is 16 tokens, sometimes it is 5 tokens. Yeah, that would be I think if I was the lecturer, if I was explaining it like this, I would bring a question like that. Basically, you have a while loop to scan each line, then you have a while loop within a while loop because you're not sure how many tokens are there per line. Yeah, my paper wouldn't be for the faint-hearted. You'd have to be you have to be an academic warrior to pass my paper. I'm sure that day that I start lecturing, UJ will become the new UCT. It's not easy anymore. So we have this first token, then we need to read the next token. So there's the next token. It's up to you how you want to read the next token, but for this time around, right, lucky enough, we have it in a double format. There's no special symbols like a hash or ampersand or something. There's no weird symbols. So I don't have to replace and do all of that. I just read the token. That's it. But then I want it in a double form. So I need to call the value of method. So double volume is equals to double right dot value of. Then what value of what? We need to pass in the string here, which is a call to the next token, right? Remember, we need to call the next token the second time to get the volume. So we've called the next token the first time here. Then we've called it the second time here. So I know the second time, the second time I call it, I know for a fact that it's gonna return a double. Then I was a string that seems like a double. Then I'm gonna cast it to a double, to an actual double. And then you're done with the question paper. Okay, we're not done yet. We need to do main. Yeah, I think we can quickly do main, then we can end the session. So I'm gonna repeat. Don't copy and paste if you're not me. Don't copy and paste. I wouldn't advise it. So I'm gonna say unprocessed waste here. Come on, let me import. Yeah, then this one it takes in waste ID. It basically takes it in the same order you read it from the file. We read the waste ID first, then I read the waste name, then we read the waste type, then we read the volume. So we're gonna have after waste name, we have waste type, comma, volume, and then done. And then you're done with reading from the file. And then it's always going to be the exact same thing. The only thing that can be different, right? Maybe it's no longer having an at, now it has X, something. Just use your common sense to change the code to adjust it to that specific problem. So we have the function, right? Remember, it's static. You can call it without creating an instance. And you need to pay attention to what it returns. So let's read the file. It returns an array list. So I'm going to copy that array list, right? So I'm going to do this. So it returns an array list. So I'm going to say array list. Then I'm going to call the first array. Remember, we are reading multiple files. Be very careful of the question. I think it should have told you. It's just that here they didn't tell you. Oh yeah, they did tell you. The main class must use the read waste method to read each text of the provided text files. After reading each file, iterate through the array list. So after reading all the files, you need to iterate through the array list and then display only the process waste on the standard output stream. All right, one new. Let's do it. But then I think no, I don't actually don't want to do it because it's gonna take a bit of time. Now I'll end up rushing things, but let's see. It won't take too much time. Maybe 5 to 10 more minutes, then we're done. Let me just do it. So we remember we can call the function by just passing the name of the class first. So it's waste file handler dot. Then you call you call the function, right, which is read waste. Then read waste, it takes in a file handle, meaning you need to instantiate a new file object. So I will just simply say new file. It's up to you. You could go there at the top and say files custom. That's a lot of necessary stuff. So I'm just gonna say new file, then import. That's how easy Java is. You don't have to remember in which header file or what is stored in. Just right click and say edit, import. So we have this. What are the file names? So we have waste info 05, waste info 10, waste info 15. I think it means the number of file of waste products that are there. So we have 05, 10, and 15. So let's start with waste info capital I. You have to be very careful with how you read the file name. So else it's not gonna run. So we start by reading the waste info 05.txt. Then we repeat that whole line again to read the next file because they said you should read all the files. Then I read again here, read again here. This will be 10, this will be 15. Then remember, you can't use the same variable. So I'll say this is waste 1, waste 2, waste 3. Then these are all the wastes, right? It's up to you how you want to structure it, to be honest. It's honestly up to you. What I can do, right, to save your time, to save yourself time, instead of creating 3 for loops, you can use 1 for loop. How do we do that? So an array list is a method. Remember, array list is a method to add, right? Called add, which adds 1 instance. To add another whole array list to a current array list, there's a function called add all, which just simply means add all elements from this array list to this current array list. So I'm just going to simply add waste 2 and waste 3 to waste 1, then only use waste 1. So I'm going to say add all wastes, or add all waste to waste 1 instance. So I'm going to say waste 1 dot add all, followed by the name of the array list. So I'm going to start by adding waste 2. So what this does, right, it takes the array, every element inside waste 2, it adds all of them into waste 1. Then we do the exact same thing and we add waste 3. Then now all the three array, all the 3 waste, right, they are stored inside one array list. Why am I doing that? So that when I use the for loop, I don't create 3 for loops, I create 1 for loop to save myself time. So I'm gonna do the for loop. It's up to you whether you do it for each loop or whatever, that's up to you. So I'm gonna do if, let's see, do I need the index? That's the important part. Nah, I don't, because they see the logic that they want you to use. They said after reading each file, iterate through the array list and display only the processed waste. So it doesn't matter about, we don't care about the index. So I can use a for each loop. If we cared about the index, then I'll use a for loop. Basically, I'll go through all the indexes. So I'm gonna say for each loop, at each index, it's of type waste, you see. At each index, it's of type waste. So I'm gonna say waste, then just call it waste. Don't say W. Remember, you need to use meaningful names. And remember, I said all of the waste is stored inside waste 1. So waste 1. So we're going to iterate through waste 1. So there's waste 1. We're going to iterate through it. And then they told you that you should display only if it's a processed, right? Processed waste. How do you check if it's a processed waste? There's a keyword in Java called instance of. Remember, Java allows you to add child instances inside to this array list because child instances are their base class, right? Basically, a processed waste is a waste. So therefore, you can add it to a waste array list. But then it's still stored as a processed waste. So you can, it's still stored as a, it's weird. There's this, what is it called? Yeah, there's that topic. I remember I was learning it, right? I was reading it on hyperskill.org. They did mention the real reason why that is, but then that's going to take a lot of time to explain because now I have to do diagrams. That's going to take a lot of time to explain. But I get why we need, really, really get why we need to do, why this is possible. And what we're about to do right now, why is it also possible? So I'm going to do an if statement and say if, and then I'm going to check the instance, right, which is the object, this waste. I'm going to check if this instance, I'm going to use the word instance. If this instance is of type, basically, how do you check what data type is that instance? You can say instance of, right? You use the instance of keyword. Then you pass the data type here. That explains what, basically checking, and the data type has to be a reference type because we're using instance. Listen to the word itself, the word instance of, meaning these are instances, these are reference types that we're dealing with. So the data type you have to pass there, it's expected to be a reference type, meaning a class. So we're trying to check if this instance is an instance of processed waste. Processed waste. Because they say we should only display processed waste. Then import Then we now cast, because we now show we needed to make sure that it's a processed waste first. If we're not sure when we try to cast, right, we're gonna get what we call a class cast exception. So we need to avoid that by checking if it is of that type. If it is of that type, then cast it to be that type. That's simply what you're doing here. So cast it to be that type. That means I need to create a processed waste instance. Then cast. Remember the value of method, right? You might be like, say, why don't we use value of method here? Then I'm gonna ask you, in any of those classes, is there a value of method? Nope. So we use the normal Java way of casting. Value of is part of only the Java classes, meaning the Java standard classes, meaning the classes that come pre-installed with Java. Most of them have the value of method. So I'm gonna cast it to a processed waste. What am I casting is the instance called waste, because I've done an if statement to check if it's of that type. So now I know this variable is storing the instance of process waste. That means I found the process waste, right? So let me put this. So since we found the process waste, now it's simple. We're basically done now. We can just simply call the methods to print. What is process waste? I don't see the accessors, so I don't know. They're in the base class. We have get ID, get name. So we need to use what is this? We need to use the accessors to get the information. We have get volume. Remember, process waste, it has three things. It has waste ID and waste name and get volume and volume. So we need to use those accessors. So let's use them. And they said in any form, right? That's up to you how you display. Me, I'm gonna display. Okay, you don't have to be fancy like me, but I'm gonna create a counter. Like I said, the counterpart that I'm about to try now is totally unnecessary. So I'm gonna start at 1, right? So that it starts counting at 1. Then I'm gonna print sys out. All right, then I'm gonna print 1, 2, 3, 4, 5 space. Then I'm gonna say this is processed waste. Then I specify the process waste number. So I'm gonna say plus count to say this is process waste number 1, number 2, number 3, and so forth. It's not necessarily, yeah, they said in any form. So I'm just choosing my form or my way of doing it. Then I'm gonna put closing things, the hyphens. So yeah. So it's gonna say process waste 1, process waste 2, process waste 3, so that I know the different process wastes, right? So I use print line so that the next thing I display is gonna be displayed after this line. So now I can comfortably the next line print the information. So yeah, I'm gonna use printf. These days I'm loving printf, so I'm gonna say sys out, and I'm gonna use printf function, right? Then I'm gonna say we remember with waste ID, so I'm gonna say waste ID colon followed by the waste ID here, which is going to be %s because it's a string. Then %n for a new line character. Then comma, and to get the waste ID. Where do I get it? There's the instance here, processed. So I'm gonna say processed dot get ID. Then done. Then the next thing. Then now I'm not gonna explain because I did explain this thing. Waste name is also a string, so percent and then processed dot get name. Then the last one is the volume. So sys out, sys out volume. It's a double, so it's a float. So I'm gonna round it off to 2 decimal places. So %.2f and then %n and then processed dot get volume. Then just, okay, I need to say printf, not print line. Then just for control J, I'm just gonna put a closing. For the closing, what is this thing? Closing hyphens, so that it's, I don't know. There's no need for it, but I'm just gonna put it like this, right? To make my output print. Then for the next output, remember it's gonna display process waste 1, process waste 2. So I need to put %n, a new line character, but I want to be like, I want to be a decent space, basically 2 spaces. So I'm gonna put %n twice, just to have 2 backslash n, or 2 new line characters, right? So that you have that space, you see that space that I'm talking about. Then I run it. Couldn't find. Yeah, I couldn't find because I was rushing things. You need to specify which folder. You see when you just say waste info.txt, Java, it's kind of weird, Java, right? It's gonna assume that it's in src folder. That's not the way it is. It's inside the data folder, so you have to tell it. You have to say in the data folder / meaning go into the data folder. You'll find that file. So that's what I was missing. So all of these files are in the data folder. Then I'm gonna run it again. Let me close this, close the console, run it again. Notice something, not to brag, but notice something. My code ran on first attempt. No, no, what errors? But then there's small error. I guess I'm not 100% perfect. You see, I forgot to increment the count. But you notice that it ran on first attempt. Okay, second attempt, technically second attempt. But it's better than the amount of attempts you guys still have to do. You see, that's what differentiates people apart. That's what they call experience. I'm sure now you understand why they want experience in the workplace. That's how much, that's how helpful experience is. So I have this, I need to increment the counter. Yeah. So I'm gonna increment the counter after here. I'm gonna say counter plus plus. So that it counts the current number, it prints the current number of the processed waste. There's no need, right? But it's kind of helpful. You see, this is waste 1. It's kind of helpful because now I can know that there's 18 waste products that we read without having to count them manually. You see, kind of helps. So there's the output, and then you get your 100%. So there's everything. These are all, yeah. So before we close, right? So that you don't be like, say is lying. If you call the next token the number of more than the actual number of times, you're gonna get an error. Let me show you. Let's say I'm just gonna reuse waste name, right? Let me just do this. I'm calling next token 4 times, so it's gonna actually crash here. You see here, this is the 4th time. The 3rd time I call it here, it's actually gonna store that 12.4. It's gonna store it here because that's the 3rd time I call it. Then I call it the 4th time. There's no fourth token. Then let me run it. Bam, kept at 40%. So that you don't think I'm lying. I'm not lying. You need to go study the textbook. There's no This is not the ComSci but you can get like and get distinction. You can exit the venue with and the 40%, right? Do you know what it means to be kept at 40? You are kept at 40% if your code is 100% correct and you forgot maybe a semicolon or something. But your answers are 100% correct. That's when you get the maximum 40%. Meaning you wrote the code exactly like the way I did. That's when you get the 40% if it crashed. If you don't, you're probably looking at 20 something percent, 30 something. So yeah, those who thought they can avoid and cram, there's no cramming, Papa. You must go read the textbook. You see one mistake, if you don't know the number of tokens, kept at 40%. And they won't smile with you. They won't be like, it's not running, right? And then you expect us to do what about that? Did you read the question paper? It says if it doesn't compile, it's kept at 40%. And I think they do emphasize it quite a lot. I think it's at the beginning of the question paper, right? So let's go. Did they forget to put it? Supposed to put it somewhere. I don't know. I'm too lazy to check for it. Yeah, how come they forgot to put it? Yeah, they're gonna give students false hope. Eh? Yeah, it's kept at 40%. Just remember they forgot to put it in this question paper. So yeah, that's it for today's tutorial. It's quite a lengthy one. Not too lengthy, but just an extra 20 something minutes. But I'm sure it was worth it. So yeah, hope you guys have a lovely evening. I know you guys don't sleep. Probably gonna sleep around mama 4 a.m. Some of you. You guys are spiritual. Like people are doing voodoo that time. You're awake. Or it's probably you guys doing the voodoo. You never know. So yeah, that's it for the day. You guys can leave.